Hello everybody, good morning. Good morning all. So this is the new timing and the last 2 weeks of our network analysis guys. So let's start. Let's start the class. So this is Bhima Shankar. I did my MTech from IIT Kharagpur. I have around 10 years of teaching experience in GATE and ESE throughout the country. I'm expertised with the subjects of network analysis and digital circuits. Right. So we are here to discuss the comprehensive course of network analysis. So today onwards, our timings are changed to 9 a.m. to 10 a.m. So this is our new timing, guys. Okay. So let's start. Good morning. I am fine. Thank you. Love you all. So let's start. So if you want to plan for an Academy Plus subscription, guys, I want to inform you one thing. These are the last. Today is November, right? So these are the last 3 months of your preparation. So I can give you some suggestions whether you want to take the subscription or not. You can decide it, but some information I will provide you. Just a minute. Yes. So, right, if you want to take the Plus subscription, you will be having unlimited access to the live classes and also recorded. You can watch the old classes, new classes, anything in any number of times. You are eligible for all batches of an academy, whether it is a crash batch, whatever may be rank improvement. Once you take the subscription, you are eligible for everything. You have the subscription in both the languages, Hindi and English. That is, once you take the subscription, you can watch the classes in your comfortable language. No restriction. Once you take English, only English or only Hindi, you can watch both. So regular doubt solving sessions, unlimited practice for your exams. That is, you can have regular exams, what we call then unlimited practice of the questions, previous year questions, everything under one subscription, guys. So if you plan for plus subscription, these are the prices. If you apply my coupon code Shankar10, you should apply this code whenever you take the coaching. Remember this code. This is the code for your joining. That is Shankar10. Once you apply this code, you will get 10% extra discount, guys. Then for 1 year, the charge will be like this. For 18 months, this is the price. And for 2 years, this is the price. Originally, 2 years ka price kitna 44K. After 10% discount of what is that 4.4K, you get it for this price. So if you are second, third year, you can plan this one, right? If you are third year, you can plan this also, right? So final year, sir, pass out, sir. If you are aiming only for 2022, if you are aiming for only 2021, last 3 months you can take subscription. These are the last 3 months. So I am saying you for 3 months the subscription fees is 13,750. After our code discount, you get it for 12,375. So there is no much increase in the price even after 20th also in this 3 month subscription. So if you want to join, I mean if you are aiming for 2021, अभी तक मैंने गेट में YouTube में कंप्लीट किया सर, जो बाकी टाइम पे with less price I want to study, this is the best option for you. 3 month subscription ले लो and you can complete all the classes, previous वाला classes, new classes, any class, no restriction. You can watch unlimitedly all the required. I need few subjects, sir. Oh, few subjects you can prepare in these 3 months. So these subjects I'm feeling difficulty that I want from plus. Yes, you can take this choice. So 3 months may it will be 12,375. So you can message me in Unacademy app for any kind of queries. Just search my profile name there. You message me, I will help you guys. So Shankar10 is the code you need to apply. So if you go for iconic subscription, you will be having personalized guidance with the digital coach and personalized analysis towards your preparation. It is available only for 1 year and 2 years with a price of this much. Okay, so let's start the class. So good morning everybody. Rahul, I don't know which transco exam you are writing. I don't know the transco of each and every state syllabus. Subject to same hai. It depends, right? So chalo, let's start the topic magnetically coupled circuits. Right. So the name itself indicating here today mostly I will give you the necessary foundation for magnetic coupled circuits. By using this information tomorrow onwards we will be solving the problems. Okay. So what are the magnetically coupled circuit ka meaning kya hai sir? Please listen here. So my course plan is like this guys. I want to explain that also. Magnetic circuits may take 3 lectures. Then some network synthesis basics also. Not much, just basic part. That also completed in the third lecture. Then I will move to three-phase circuits. Three-phase may take 2 to 3 lectures. With enough all in this three-phase circuits, all previous year gate questions I will solve in the session. So because this is most frequently, this is only for double E. In this part, EC people can skip. Okay, this EC people can also attend, I will suggest. Okay, so here because you will not specify directly, there is a chance AC analysis may anything can be asked. Okay, so this part I take 2 to 3 lectures for you. All previous questions concept I will give you, all questions I solve. Why? Because for electrical every time one question is compulsory coming from this, that too very easy. That too very easy, and it is useful for you in your machines, power electronics, everywhere, power systems, all your core subjects requires three-phase basic knowledge. That we will discuss after these three. Then I will discuss graph theory for you. That may take 2 hours or 2 lectures. That will finish your syllabus. So around 8 lectures it will take. Last 2 lectures I may take practice sessions and quizzes of all the topics we discussed, which will make the quick revision. This is the plan I am going to take. So let's see. So let's start. Chalo. So what are magnetically coupled circuits, sir? Okay. So magnetic coupled circuits are the these are the circuits where networks or elements are connected magnetically. And after this topic, with three phase only Sanket. Okay, this where it is connected magnetically. Okay, so listen here. So suppose if you have a current carrying conductor. If you have a current flowing through it, then you get the magnetic field lines. You can say flux linkages. If this current is a time varying quantity, then you will get some induced EMF here. You get if it is a constant, you don't get any induced EMF, but if it is a time varying quantity, definitely you will be getting an induced EMF. So the induced EMF is generally called as self-induced EMF. It is called as self-induced EMF. Okay, sir, fine. So here, if I bring another coil, otherwise I will write with a different color. If I bring another coil in the near vicinity of these field lines, then what happens? These lines may cut this coil also, and because of this I am getting some induced EMF here, that is called as mutually induced EMF. Every problem may you should keep this in your mind. Mutual induced EMF is always due to current in some other coil. It is not due to current in its own coil. It may be upward, it may be 3 coils, 4 coils, anything. The mutual induced EMF is always due to current in some other coil. So आपके लिए एक एग्जांपल देता हूं, देखो. You are using Wi-Fi connection at your home. Okay, आप Wi-Fi यूज कर रहे हैं, आपका घर का Wi-Fi यूज कर रहा है. Okay, that is your self. Sometimes you also do one thing. What is that? सर मेरा फ्रेंड इज देयर, नाइबर होम इज देयर, नाइबर होम के पास पे जाके उनका वाईफाई आल्सो यू विल यूज. Okay, you might have done it, yes or no? In any time you might have experienced this. This kind of is called mutual. That is due to some other, it is not due to your Wi-Fi, someone else you are using. Same way you are having here, due to current in some other coil you are getting voltage here. This is what we call mutually induced EMF. Okay, this is what we call Mutually induced EMF. Okay, sir. I am using my friend or neighbor Wi-Fi. Okay, sir. What about my neighbor, sir? Suppose by chance you also, okay, you also have some current. That is, you also have some source. Then you will also have this flux linkages. Then your lines also will touch this fellow. Whatever distance from x to y is same as y to x. If you use your friend Wi-Fi, definitely they will also use yours. Then they will also get some mutual induced EMF and also self-induced EMF. Okay, so self in the own coil, mutual in the some other coil. Now you see here, the mutual is can be positive or negative. Can be positive or negative, sir. It depends, sir. Dekho, if the lines are in this direction. These lines are in this direction. That is, they are in the same direction. They will be adding together. It depends on your winding direction and current flow direction. It depends on your winding direction and current flow. The flux direction can be additive or can be opposing. If the opposing हुआ तो क्या होता है? Subtraction होता है. If they are in the same direction, they will be additive. This is what we want to say. The mutual coupling can be additive or can be opposing. I'm giving more theory initially because this will lay the foundation for understanding the critical problems later which we do. Okay, so they can be aiding or opposing depending on the flux, magnetic flux lines. So this aiding or opposing, hamesha we cannot see the winding direction kaisa. Is it winding is like this, okay, or is the winding is like this? We don't know. Every time we cannot check the winding directions and all to find which where the current direction is and all those things. For that, to make your analysis easy, we take the help of one thing called dot convention. Dot convention will make your analysis very easy. So let's see these points I have added. Listen here. First point, see. What is the first point? These are the circuits in the presence of mutual inductance, which is due to mutual flux. Okay, please understand the name of the topic, magnetically coupled. Please listen. For electrical coupling, you need physical connection between the wires. Then only current can flow. You need a closed path. For magnetic, you need a closed path, but not conductor closed path. That is, physically they may not touch each other. They are physically not coupled. Electrically may not be coupled, but they will be touched with the magnetic lines between them. Okay, so I want to say one thing. Suppose you have a resistor. Another resistor also there, means they must connect physically. Electrical conduction के लिए continuity required. But here magnetic conduction के लिए what you require? These lines should touch each other. They need not touch physically, but these lines should influence each other. That is called magnetic coupling. They are not physically connected, but magnetically coupled to each other. Okay, guys. Now see. So these are the circuits in the presence of mutual inductance M, which is due to the mutual flux phi. What is the next point? The mutual flux may be additive. It may be additive or opposing also based on the dot convention. Originally depends on the winding direction and how the current is flowing, both the directions. Okay. So originally that is where your flux will be additive or opposing. Okay. If the current is entering or leaving through a dot, okay, this dot convention, how to understand, I will tell you. See here. Firstly, I told there is a possibility for editing and additive and opposing. Na? So based on this, we follow the rules like if they are additive, we keep the dots such that they may be current may be entering from both the dots or current may be leaving from both the dots. If they are opposing, current will be entering from one, leaving from other. These things I will explain with example. Don't worry. Okay. Thank you. Chalo. Say you have some kind of core like this. Okay. Suppose you have a winding like this. Okay, say X and Y. Suppose the current is in this direction. It is entering at X, leaving at Y. So this is the basic, please understand here. So the current is coming like this. It goes back and up, assume karna. Okay, back say it will come back. Okay. So what is the direction of the flux? I hope you know Fleming's rule, right hand rule. Okay. Is it exterior of X or is it exterior of Y? This is the current direction. Then what is the flux direction, guys? It is perpendicular and also what? Yes. Actually, right and left तो confusion होता है क्योंकि we are mirror imaging maybe. So please see here. This is the direction. Yes, correct. I hope you understand. Just a simple rule is you keep your hand on the screen. You keep your hand on the screen to the direction of the current. Then this will tell you the direction of the flux. Okay. So suppose now what I am saying is take one more coil. One more coil. Okay. Let me take one more coil and take one more winding. Okay. So if this winding, एक minute, I will save this image. It will be helpful for me. Okay. If this winding is like this, okay, XY ले लिया, AB ले लो. Okay. Now it depends on the current direction. There are different possibilities. Please see here. It depends on the current direction. So let me take all possibilities. Suppose here the current is taken A to B. हमेशा A to B नहीं होता है. Okay, if it is A to B, then what is the flux direction, sir? Same. This is called additive. This is called additive. If both the fluxes are on left hand side, okay, means if the current direction नीचे है तो भी, then also additive आएगा. But both the fluxes should be in the same direction. This is how sometimes winding and current direction may be given. You should not worry. Okay, so please listen here. Generally we represent like this. You have a coil, another coil. Here is the dot. Here is the dot. Current is entering through the dot and current is entering through both the dot. This is what we call aiding connection. Okay, this is what we call. There may be some series connection here. I'm not connecting them. Okay, I'm just showing the magnetical connection here. Both the coils are in series. You can connect them. Nothing wrong. You can connect to X and A, X and B. Two possibilities hai na. I am taking both the possibilities. Okay, then what happens? Okay, so now another case. Listen here. Just a minute, guys. Suppose if current is entering here, then please see back say enter हो रहा है. Okay, it will come like this. Okay, I cannot show you my hand properly. Then it is coming like this. If coming like this, आपका flux ऐसा चलेगा. Yes or no? With respect to direction of the current, it will be like this. This is the case of opposing. So here you can represent the dots like this. This is what we call opposing. I hope you understand different possibilities. Here you take down, here you take up, both downs, one down, one up, different possibilities according to your comfort. You can take all possibilities, but rule is same. See the current direction, right side flux. See the current direction, right side flux. Both the fluxes are opposing to each other, are in the same direction. Same direction into opposite direction. It is opposing. Okay, so if you understand this, remaining story is very simple. Okay, remaining story is same, very simple. Now see here, series before going to series. Listen here. You can have multiple possibilities here. have a coil L1, L2. Okay, current is entering through dot, entering through dot. Is it aiding or opposing? Please tell me. You should tell me whether it is aiding or opposing. How much it is linking. Please listen here. These two coils can be kept in multiple ways, one upon each other, one side by side. Connection may be series. Connection may be series. You may be connecting the wires simply. Connection may be series. But please understand here what I want to say is they may be very close. They may be very far. What is the field in between them? All these things will come account for how much link is there between this wire and this wire. How much is the mutual inductance linking between them? So this is the aiding or opposing. Batao? Yes, very good. That will be given by mutual inductance. Similarly, suppose here it is dot like this, here dot like this. See here, after current, you assume current is coming like this. Current is leaving through dot and current is leaving through dot. Both the cases. Then what is the mutual inductance? M. Here it is what we call aiding. Suppose my current is entering through dot here and leaving through dot here. Now tell me guys, this example, what is the answer? In this example, what is the right answer? Tell me in these two cases. Very good. What is that? Opposing. This is what I have given in the first slide. See here, these are the circuits in the presence of mutual inductance, which is due to mutual magnetic flux. The mutual flux may be additive. It is adding or opposing based on the dot convention. If current is entering or leaving through both the dots, then it is aiding. If current is entering or leaving through, entering in one and leaving through other, it is opposing. Very good. So no confusion now. Another important point this is. Please read this point. If the current entering through dot in one coil, अगर एक coil में current is entering through dot, then the mutual induced EMF should be taken as positive at the dot of other coil. If the current is leaving through dot of one coil, then mutual induced EMF is negative at the dot of other. How to understand this, sir? I will take one example and explain you. Here there is a dot. Current is entering through dot in one coil. Then the mutual should be positive at the dot of other. Similarly, if current is, for example, entering through dot here, examiner has given dot here, you should take positive. In another sense, you can say dot must be same polarity. You can also say like this. Dots must be having same polarity. Suppose, please listen another case. If current is leaving through dot here, then mutual induced EMF is negative at the dot of other coil. This is how you will need to take it. It will make your analysis easy, guys. If examiner gives dot here, then take negative. This is what we need to follow. These are the rule I have given here. If current entering through dot in one coil, then mutual induced EMF is positive at dot of other coil. If current is leaving through dot in one coil, then mutual induced EMF is negative at the dot of other coil. You can see in both the direction it is the same rule. These are only for mutual. Some people will confuse. Sir, here some voltage source is connected, sir. Will it be negative, sir? No. Self will be as it is. Self will be as it is. Its source will be as it is. These polarities will be for mutual only. That is, the mutual may be additive to this or opposing to this. That rule we are speaking. We are speaking only for mutual, not for self. Please understand. Chalo. Very good. Now we are starting the next part of the basic series connection. I will go little slow intentionally. Why? Because आपका बेसिक अच्छे से होना चाहिए. ओके, थोड़ा सा फाउंडेशन ले लिया, Abhi, let's take the possibilities of the series connection. Please see here. Let me draw this. Already I have shown you how to take series connection in multiple ways. Now I take one example and I will discuss it. I think compared to evening, I feel more comfortable in the morning class because morning we are very fresh. All my energy is available. No exhausting of energy. Provided you sleep properly at night. Right? So let me take this coil as L1, L2. Then the mutual induced EMF, let's take it as M. Okay, guys. So please see here. This is the current I. Yes, Balkrishna. Okay. So here current is entering through dot, entering through dot. I can say 100% it is additive only. So let's take this voltage as V1, this voltage as V2. Yes, this voltage is V. Okay. So please listen here carefully. Now listen here. What is V1, sir? It is the self-induced EMF, that is L1 d I1 by I2, that is I1 by dt, that is the current in the first coil, plus mutual induced EMF. Why plus, sir? Because it is aiding M times d by dt of M times d by dt of current in the second coil, sir, that is I2. Okay, sir, fine, sir. But because it is series, I1 equal to I2. That is L1 di by dt plus M. Second coil ka current also I only na, so we take di by dt. Always mutual induced EMF is due to current in some other coil only. Okay. So in the same way, you can write the equation for the voltage in the second, that is L2 di2 by dt plus M times due to current in the first coil, that is di1 by dt, which will give you L2 into di by dt plus M into di by dt. That will give you L2 plus M into di by dt. So, okay, sir. Otherwise, I'll write last. Don't worry. So what is the voltage V? Hamesha never leave your basic V, KCL and KVL. V1 plus V2 is equal to, what is that? L1 plus L2 plus M plus M. You understand? This plus this equation I'm writing L1 plus M, L2 plus M, common le lo, di by dt. That will give me L equivalent into di by dt. What is L equivalent, sir? L1 plus L2 plus M plus M2M. Thank you, Vishnu. So L equivalent equal to L1 plus L2 plus 2M. Okay, fine, sir. चलो सर, आगे चलेगा सर. देखो, मैं थोड़ा सा कॉपी पेस्ट करेगा, टाइम सेव हो जाएगा ना. Right? Uh, Please listen here. One minute. Okay. So I need to redraw it. So if you take opposing in place of plus, you will get minus. That is the only difference. Before that, I want to draw one circuit here for L equivalent के लिए. Suppose see here, you can also draw that series connection like this. L1 and L2. This is the series connection, right? And you are having M. For example, let's take these nodes as A and B and C. If you measure the inductance between A and C, you get L1 plus L2 plus 2M. Fine. If you measure the inductance between A, B only, if you measure inductance between A and B only, what is the answer, sir? That is, you apply the source between AB, you left C, then only L1 will come. If you take BC and left A, then only L2 will come. For that, I draw this equivalent without dots. Without dots, how to draw this figure? You can show dependent sources, that is one method. Nahi hai to you can represent like this. L1 plus M. I just removed dot. L2 plus M minus M. A and B and C. Will you accept this? Yes, Utkarsh. Today onwards, we are starting new batch of network analysis for plus users. That is evening 4:30 to 6:30. If anybody want to take the subscription, you can plan. And today we are starting the new subject, that is network analysis new batch in Hindi. Okay. So last 3 months, if you want to plan for, you can go for the 3-month subscription. If you are attempting only 21, 22 is also in your mind, go for 18 or 12. Okay. So let's continue, guys. Let's continue. See here, L1 plus M minus M, L2 plus M. You see here, this is the equation. Suppose you connect the source between AB, then what is the answer? L1, sir. BC, what is the answer? L2. If you connect between AC, L1 plus L2 plus 2A. Okay, so you can redraw like this. It will make analysis easy in some kind of problems. I will use it later. Okay, so let's move. Okay, is it clear, Shubham? Now, tell me, guys, if you have any queries, feel free to ask always. Okay, if you have doubt, never say repeat, guys. That is a very bad thing. Always ask where you have the doubt. Where you have the doubt, that specifically you should ask. This is the process. Okay, if you say repeat, it doesn't make any sense. If I repeat the same thing, how can you understand? Where is your doubt? You should stress. There we can explain. Okay, chalo guys. So after the series connection aiding, now we are going for series connection opposing. Chalo. So in the series connection opposing, already we took the copy of the peak. Let us use it. So instead of placing the dots here, it is like this. That is leaving from one dot, entering from other dot. In this case, what happens, sir? You get mutual as minus. It is as simple as replacing M with minus M. Then what is the L equivalent in this case, sir? L1 plus L2 minus 2M. The mutual inductance will be equal to L1 plus L2 minus 2M. I'm very sorry, my dear students. I want to inform one more thing is I forgot to upload the notes from last 2 days. Today I will surely upload everything. I'm sorry for that. Thought as a busy, not able to do it. Today definitely I will share. Okay. So what is the L equivalent is L1 plus L2 minus 2M. Okay. Is it clear? How to decide? I told everything, Rahul. You are not in the starting of the class or what? With respect to dot connection, how to decide? See here, simple thing. Don't worry, Rahul. See the current. You assume you are the current. You are coming like this, like this, like this. You are entering the coil. Dot is not there. You are waiting for dot. You are entering the coil, coming. When you are going from the coil, yes, coil touched. That is, in the first case, when the current is leaving the coil, dot comes. Second case, see here, coming like this. When you are entering itself, dot comes into your picture. That is, for the first coil, I will touch the dot when I am leaving the coil. Second coil may I will touch the dot when I am entering. If you are leaving, if you are touching when leaving in one dot and entering in another dot, it is opposing. If you are touching, entering in both the cases or leaving in both the cases, it is aiding. Those things how they will come based on the direction of the flux, that is explained in the starting already. Right. So here, if it is opposing, what happens, sir? Listen here, in place of here m plus m is taken, so you will get minus m. Just a minute, guys. So see here, if it is this kind of thing, here how to draw it is very simple. This is the equivalent. Thank you, Vani. Chalo, let's move. This is the equivalent. Now, the next one we are discussing is a parallel connection. So what is parallel connection, sir? See here. So two coils are like this parallel L1 and L2. यहीं पे dot है, that is it is additive. Okay, so current is like this. After current, we should say whether it is additive. If current is from bottom, you cannot say additive. Okay, so I2, and this is your voltage V. You see here, because it is parallel, V1 is the same as V2 is the same as total V. Okay, sir, fine, sir. Now listen here. Here, what is V1, sir? It is equal to V2. It is equal to V. What is V1, sir? Or you see here, what is the V1? It is equal to L1 di1 by dt, that is self-induced EMF, plus m times, that is, now you tell me, is it di1 by dt or di2 by dt? Please tell me, is it di1 by dt or di2 by dt? Tell me, guys, is it di1 by dt or di2 by dt? Very good. It is always current due to some other coil. Current in some other coil. So it is m di2 by dt. If you have one more coil, m12, m23, like that we take m13. Right. So here additive, that's why plus. What is V2, sir? L2 di2 by dt plus m di1 by dt. Here you can write this as j omega. You can take phasor help, Laplace help, both will help you. J omega L1 I1 plus j omega m into I2. You can also take another representation is Laplace, that is s into L2 into I2 of s plus S into M into I1 of S. Whether by Laplace, by phasor, we solve this generally. I show you in the problems. Okay. So here one more thing, the current I equal to I1 plus I2. Then if you find V by ratio, that will give you J omega L equivalent. आप try करना चाहे तो आप try करके you can find the ratio of V to I. But I am directly giving you the L equivalent. I don't think it is visible there. L equivalent will be L1 L2 minus m square by L1 plus L2 minus 2m. Both are minus only. Okay, so please listen here. I can also draw this figure without dots like this. L1 di1 by dt plus m di2 by dt. Okay. So why you took dependent source? Because the current cannot change in the series. Similarly, you can have L2 di2 by dt plus m di1 by dt. This will give you your V2. This will give you your V1 and total V. Okay. So this is another way to represent your circuit without what we call dots. Okay. Without dots, you can represent like this. Good morning, Nitish. So very good. So let's move further. Let's move further. Same thing I want to do for opposing connection. Same thing I want to do for opposing connection. How to do it, sir? Very simple. See here. Just a minute. So this is your aiding connection, guys. So opposing के लिए क्या करना सर? देखो. Right. For opposing, only difference is here in place of plus you get minus. Okay. Current is entering through one coil and leaving through dot in another coil. Then in place of plus, what will you get here? Minus will come. Here also polarities will be reversed. Okay. So what will you get, sir, here? In place of, I want to save your time, so this is the best thing you can do. So simply this one, and polarities will be opposite. Then L equivalent will be L1 L2 minus m square तो same होता है, but L1 plus L2 denominator में plus will come. Denominator increases, overall value decreases. This is the formula for parallel connection in the series and parallel connection in the parallel. Sorry, in the parallel connection in the aiding and opposing. Right? This is opposing and this is aiding. Right. Very good, Nitish. So let's move to the next. Right. Let's see the example of transformer coupling. First we will discuss as it is aiding. Next we will discuss opposing. So here you have a transformer. This is V1. Current is assume I1. Okay. Here V2. Assume my current is like this. See here, sir, transformer, one will be entering, one will be leaving. Definitely correct. Okay. According to my circuit. Okay. This is the, I applied source here. That is my assumption. I am not saying about the mutual. Please understand. This current is the current due to this source. Okay. This is giving this current and this is giving this current. This is the convention I have followed. Okay. I have taken. Okay. Originally in transformer, one side dot will leave, enter, and other coil, other side it will leave. Primary entering, secondary leaving. Because primary we connect the source, secondary we connect the load. That is true. So now please listen here. It is a aiding connection. What is V1, sir? Let's take this inductance as L1 and L2. L1 di1 by dt. बताओ m plus क्यों ले लिया sir? Current is entering through dot here, entering through dot here. So it is additive. This is one method. नहीं है तो हमारा method क्या sir? What is our method? If current is entering through dot, at the other dot you should take positive for the mutual induced EMF. So rule is satisfied na? This is how you take. Similarly, if current is entering through dot, at the other dot you should take positive for the mutual induced EMF. So these two are with the same polarity. So you should take place. Two methods you can say. What are they, sir? If current is entering through the dot and entering through the dot in both the coils, additive. Okay, sir. Second method, what, sir? If current is entering through dot here, at the other dot you take positive. For which one? For mutual. For mutual. Okay. So similarly, if current is entering through dot here, for the mutual here, you should take dot, at the dot positive. That is, they are in the same polarity. So you should say additive. That is also correct. Right. So what is the condition? M into d by dt of current in the other coil. What is V2, sir? L2 di2 by dt plus M into di1 by dt. Listen here carefully. You can redraw this figure with a T equivalent like this. Why T equivalent, sir? To make analysis easy. Two-port network T equivalent can be replaced for this circuit. What is that T equivalent, sir? L1 minus M, L2 minus M, M. Okay. So this current will be I1, this current will be I2. Okay. And this current will be how much, sir? I1 plus I2. Okay, sir. Fine, sir. So can you prove both are same, sir? Definitely we can prove. Otherwise you don't accept. So let's prove it by taking KCL and KVL. If you take this voltage V and write the loop equation, What is the loop equation, sir? V minus negative to positive V. This is the inductance. Forget about the M. L1 minus M into D current I1 by dt. Positive to negative minus M into D I1 plus I2 by dt. So V1 minus L1 di1 by dt plus M di1 by dt, right, minus M di1 by dt and also minus M di2 by dt. So here you take this plus M and minus M cancels. What is the final answer, sir? What is the final answer, sir? Just a minute. What is the final answer, sir? V1 is equal to L1 di1 by dt plus M di2 by dt. Both are same. Both are same. Yes or no? I hope you understand. It is same. This and this are same. So you can prove that the second V2 also. Similarly, you can prove for V2 also. Then I can say that what is that? The mutual induced. You can replace this particular figure with this figure. It will give you same analysis. So another important thing I am giving you as a homework is convert star to delta. That is T to pi equivalent of the transformer. You do it at home. It is important. Why, sir? Sometimes examiner can give question like this. There is a capacitance connected between or some load is connected between and they may ask you input impedance of this network. In that case, if you have pi equivalent, it will always make your analysis easy. So that's why please try that home. At home, just convert star to delta. So this is here what is the energy stored is also important, which you study in your machines may etc. also, but you can see the derivation also if you want of Li1 square of L2 I2 square plus due to the mutual you get M into I1 I2. Okay, this is the energy stored. Okay, so let's try the same for opposing. Let me check if you have any kind of queries. Yes, Vani, we will do in the problems that one. Okay, in problems you will see all the even complex part also we will solve it, don't worry. So is it fine guys? So shall I move further? I hope you don't have any kind of queries. So let's move. Just a minute. अरे यार क्या हो रहा है? This is aiding, right? So in the same way we can do opposing also. For opposing what to do, sir? Simple thing. Let me edit it. That is, I have already copied aiding partner. So to save your time, right. So here, please listen. Instead of keeping the dot here, you should keep the dot here. Then plus ka jagah pe you will get minus. Replace every plus with minus. Right. See here, simple thing, simple rule. So here you take the dot. Okay, now minus. I want to explain. Wait. See here. Sir, why it is opposing? In one explanation is current is entering through dot here, leaving through dot here, it is opposing. Another explanation, listen, our explanation. If current is entering through dot here, at the other dot you should take positive for the mutual induced EMF. But mera V2 is not in the same direction. Similarly, if current is leaving through dot in one coil, then at the other dot you should get negative for the mutual induced EMF. This rule I have given in the starting. Now you observe here, आपका original and mutual are not with the same polarities, so that's why we take minus. Is this rule clear? Starting may I have given. What is that? If current is entering through dot in one coil, at the other dot you should get positive for the mutual. If current is leaving through dot in one coil, at the other dot you should get negative for the mutual. Now you observe V1 minus M and V2 minus M. Is clear? Minus ले लिया. The mutual will be here opposing. This is one way. Otherwise, the simple thing is current is entering through dot and leaving through dot. In that case also you can say it is opposing only. So let's do it. So here in place of L1 plus M earlier, now it is L1 minus M, L2 minus M and M will come. So here L1 minus M positive to negative minus M dI1 by dt. Okay, 1 minute. Sorry. Just a minute. Earlier it is L1 minus M, na? So it is here L1 plus M, L2 plus M and minus M. So please here both minus will go there, right? So please see here minus of minus it will be plus. So here plus V1 minus L1 minus into minus kya plus. Am I wrong somewhere? Just a minute guys. Minus L1 dt plus M positive to negative minus of minus plus M. Here, okay. Here it is L1 plus M. Na? If it is L1 plus M minus L1, now what is that? Here minus M. Fine. So these two cancels. Finally, you get L1 plus L2 plus coming. Okay. I'm sorry. Earlier also I committed mistake. I'm sorry, guys. L1 plus M, L2 plus M, and minus M. This is the correct connection. Sorry for that. Now it is L1 plus M minus into minus plus M. So here minus L1, this will be minus M. Okay. Okay. And here it will be plus. Okay. And plus. That's why you will get plus. You should ask that doubt. That's okay. Here it is a, sorry for that. Chalo. L1 minus M, L2 minus M and M. Okay. So minus L1 minus M. Okay. Minus M di1 by dt. So minus L1 minus into minus plus and minus. Finally, this is the answer. Right. So if it is additive, L1 plus M, L2 plus M and minus M. If it is opposing, L1 minus M, L2 minus M and M. Right. So that will finish this transformer coupling. Okay. What's the time? Time up. Chalo. No problem. Okay, guys. Then remaining part we will take tomorrow. Not an issue because only this tomorrow we start the problems. How to make impedance matching with the transformer? What is the coefficient or degree of the coupling? Those things we will discuss. Then we will start the problems from tomorrow. So we will meet tomorrow again at the same time daily 9 to 10. Let's meet. Don't miss it, guys. So again, I'm saying if you want to plan for 3 months subscription, those who are pass outs or final years, this is the right time. It will be just 12,750 for you if you apply my coupon code Shankar10. So okay, guys, so you can follow our Telegram channels. There you will be getting access to our notes, links, every single update. Okay, follow our channels, Gate Questions, Gate Telugu and Kreatryx, all channels for more and more number of initiatives. I hope you know it. For electrical engineering, I completed 2013 to 2020 all previous Gate Questions of networks part in this. Just go to playlist and see the network analysis part. Everything I have completed. And I am planning this month EC part also. Then digital also we will. Like other subjects, every other our faculty also doing it. Okay. So, okay guys, our timings are every day 9 to 10. Please keep this in your mind. So, log this time every day. We will meet tomorrow. We will be doing the problems based on this. Okay. So, if you have a circuit with multiple loops, all those things, this kind of problems, in this case, how to find the mutual, 1 and 2 may mutual, 1 and 3 may mutual, how to do, all these things will come tomorrow. Okay. Bye bye. Thank you. Thank you. Thank you. Love you all. Bye bye.